Alrighty. Well, I will begin with a word of prayer here once I get up here. Again, sorry I'm late. Don't worry, I'll make up for it by going late. So, dear Heavenly Father, we thank you for this day. I thank you for these students. Just ask you to bless our time here to study your creation and just help us learn a little bit more about math and just to resolve any questions that remain, Lord. You know my prayer, Lord Jesus. Amen. Now, one of you asked me to solve or do something similar to something in the mission, and annoyingly, I have left my copy of the mission back in my office, so you'll have to tell me what the problem was, if that's okay. You know who you are. What's that? Which one is it? Oh, up there. I'm looking through. So x squared plus 4x minus 7. So the instructions on this problem, which problem is it? Problem what? 16A. Problem 16A. So it was x squared minus 4x plus 7? Minus 7. Oh, minus 7. All right. Plus 4x. Plus 4x, okay. And it's just that, or is it equal to 0? It's just that, right? Okay. So the questions say to complete the square and to factor, right? If possible, if not, write prime, right? Okay, so let's see here. I don't want to work your homework problems. I need to change this ever so slightly. Like, I don't know, x squared plus 6x plus, minus I don't know, 7. I think that'll, oh, that's too easy. Now it factors. That's no good. I don't want it to be easy. This might factor, I have no idea. Minus, oh, I don't know. Does 8 factor? Rats, that factors too. Oh no, that doesn't factor. Okay, so let's try this one. So the question says complete the square. All right, so how do we complete the square? Do what? The formula. Ah. What we look for, I'll let you look.
X plus 6 over 2 squared.
So what's 6 over 2? So we do x plus 3, we square that, right? So so we take this number here, right? And divide by 2. That's part of it, right? Put that there. And then, to be fair, we have to subtract, what is it?
So I was wondering, why would it be 3? Because 3 squared is 9, not 6. So why would you square the 2 and then...
So to be fair, I have to subtract 3 squared here, which is 9. And let me just, I mean, you're asking why. Let me explain why. So the 8's still there. So let me just focus on the red piece and explain to you why that's what we do. So if we look at that, this right here, right? Let me just do it over here. So what is x plus 3 squared? It is x plus 3 times x plus 3, right? So when we FOIL that out, we get x squared plus 6x plus 9, right? So if you solve that, you get x squared plus 6x equals to x plus 3 squared minus 9. See, the point is that we can replace these first two terms with that square minus 9. It's an identity. So it's always this. We always take half of the coefficient of x, we add it to x, we square that, we subtract the square of the thing we added over here, and that will match what we started with. It's just a way of rewriting the variable into a square. Is that okay? Then what? So the question, your problem says factor it if possible. Can we factor this one? Well, yeah, we can. And I think the same is true for yours. Actually, the problem that you have in the homework is easier, because when you complete the square on this, what happens? Instead of getting this ugly, we get a minus 17 here. What would happen for your homework problem? You get Oh, it's still ugly. Never mind. It's just as ugly. My bad. I thought it might have been a perfect square for a second there, which makes things, you know, like a little bit easier to look at. But this is 17, which is fine. We can factor that. How do we factor it? Just like this. So x plus 3 plus the square root of 17, x plus 3 minus the square root of 17. And that's how that factors. Once we complete the square, we always have the pattern. The pattern that we have is this, you know, a squared minus b squared. And we remember a squared minus b squared, we can factor as a plus b times a minus b, right? So the thing that might not be immediately obvious is like, how is 17 a square, right? That takes a little imagination, but 17 is the square root of 17 squared. That's the kind of tricky part there, yeah? So that's how you do part A. You just complete the square. You'll get minus a number, so then you can do plus the square root of that number, minus the square root of that number, factored just like this. Pretty. Of course, you'll have x plus 2 and like plus root 11, x plus 2 minus root 11 for that homework problem. I'm sorry, I think I solved the homework problem. But I didn't write it down, so it doesn't count. Anyway. Oh yeah, this right here is the answer. So the question was, we factored, you know, f of x, let's say. I'm gonna give this a name. I'm just gonna call this f of x, so I don't have to write it again. Sometimes it's nice to give it a label. Name names, you know. Let's see. And so what else would you guys like me to? Anything else like me to review from last time? Aw, man. Well, this is just not a good day. I got no juice. I guess it's not too dirty. And did I bring the air horn? I didn't bring the air horn either. Oh, man. Well, hopefully it won't be. Yeah, go ahead.
I had one on the mission topic too. It was 6x squared minus 19x.
6x squared minus 19x minus 7?
Yeah.
And what's your question about? Like, does it say equal to 0, or does it say factor that?
Factor the quadratic polynomial
Okay.
given below.
So just to factor that. So what would you guys do? By direct factoring or completing the square. So I completed the square over here for this one, right? Direct factoring, that's just, I sometimes call it guess and check, you know, so I put like a 2x here maybe, and a 3x there maybe, and go from there. What would you do? I mean, I'm not sure this is going to work. If this doesn't work, if we can't guess it, then we'll fall back on the completing the square thing. But that would be unpleasant, because it's going to have some fractions. Like a lot of fractions. Any ideas? Well, I mean, 7 is kind of limiting, right? Because this, you're either going to do minus 1 times 7, or you're going to do 1 times minus 7, right? I mean, in terms of like elementary, if you want to write 7 as a product of whole numbers, that's kind of it, right? Well, integers, I should say. What's that?
What number on the homework is it?
Oh, I don't know.
17F.
17F? Oh, there's F parts to 17? Who wrote this homework? Some sort of monster. When's it due?
Next Tuesday.
Valentine's Day? Oh, that's right. That's right. It's just according to my design. Actually, that's coincidental. I just don't pay any attention to Valentine's Day. Anyway, let's see here. I don't know, maybe plus 7 minus 1. Does that work? What do you get there? Plus 21 minus 2. 21 minus 2 is plus 19, right? This is almost right. What do we do? Reverse. Yeah, flip the signs. And I think I have solved one of your homework problems. My apologies. But there it is. You'll forgive me? Does that make sense? I mean...
So where do you get from like the 21, how do you get to the minus 7?
Oh, so the process is this. Here's the process. Number one, set up this, right? Now, is that written in stone? I mean, you might have to try this. But I hope for the 2 and the 3 to work. If the 2 and 3 fails, then I fall back on the 6 one, Okay, this is set up the thing. And then number 2, you look at the constant. And you ask, how can that be factored in terms of integers? So in terms of integers, well, this is it's prime, right? So it's either minus 1 times 7, or it's 1 times minus 7. So they're kind of it for your choices. And then step 3, try it. And then you check by multiplying, which I never write down, right? But I think about the multiplication in my head. See, because when I multiply this out, I get 2 times 1, which is 2, minus 7 times 3, which is minus 21. Minus 21 plus 2 is minus 19, which is what has to happen here. So that, basically it's guess and check. The checking is multiplication. Now if you need to write down the multiplication, do it, right? But I'm not, because some of you just write down everything I write, and if I put too much detail on the board, then I'll lose you. It is true. Yeah.
What is the formula for vertex?
The formula for, okay, so example 1, so suppose you've got f of x equals to, I don't know, 3x squared plus 6x minus, I'll make it easy, 12. I want to find the vertex of this parabola, right? How do you find the vertex? What I do is I complete the square. So factor a 3 out. That gives me x squared plus 2x minus 6. All right, so when I have a leading coefficient, which is not 1, like the first thing you want to do is factor that out and make it so you have just a plain x squared to work with. Now complete the square. What's completing the square on the... Oh, did I do something wrong? Oh, yeah. Man. Eventually I'm going to have a soundboard, so I can play the coffin dance when that happens, but... Let's see here. So that's x plus 1 squared minus 1 minus 4. Now there's a couple of different paths we can go down here. Let me show you. So you asked what the formula was for the vertex, and I'm not giving you a formula. I'm actually just showing you how to find it. Because if we complete the square, we can find it. And I'll talk about the formula here in just a second, but if we look at this is 3 times x plus 1 squared minus 5, right? So one thing you could do here, maybe I also ask, what are the x-intercepts, right? What would the x-intercepts be for this parabola? See, to find the x-intercepts, you want to factor, right? Because where it's 0 is where the x-intercepts are. This is easy to factor because, well, we did it. It's not easy, but it's I mean, what I'm trying to say is, there you go, now it's factored. They're not nice to look at, but there they are. I mean, the x-intercepts are apparently -1 plus or minus the square root of 5. These are your x-intercepts. That's where the x-intercepts are, right? You're like, but I asked about where the vertex is. I know, I'm getting back to it. So let me go back up a step to here and go, okay, well, see this, I can say f of x is equal to what? Well, multiply the 3 through. See, I've got 3 times x plus 1 quantity squared minus 15. So, generically speaking, once you have the formula for the parabola written in that format, you can just read the vertex off of it by inspection. So this has vertex at -1, -15.
Where did that 15?
That 15.
Did you multiply 3 times 5?
Oh, yeah, exactly 3 times the -5. Okay, so that's, to me, that's the best way to find the formula for to find where the vertex is to complete the square and to put it into quote-unquote vertex form. Vertex form for a parabola is this. It's a times x minus h squared plus k. This is the vertex form. This says that the vertex is at h comma k manifestly, so you can just like look at it and see that.
And so you got the -1. Is that because that's opposite of what's in the parentheses?
Yes, exactly. So the x-intercepts are where these are 0. So if I set this factor equal to 0, I get -1 minus root 5. If I set this one equal to 0, I get -1 plus root 5.
But I'm talking about for the vertex, like where it's x
Ah.
plus 1 squared.
Yes, right. And like an intuitive way to make sure you're on the right path, the vertex is where the formula is either largest or smallest, right? So what happens when I plug in x equals -1 into this formula? See, like f of -1 is what? What is f of -1? It's 3 times 0 minus 15, right? So f of -1 is minus 15, and in fact, that is the minimum value that this parabola ever attains. So for what it's worth, the range is minus 15 to infinity. So these are the things we talked about some last week. Now, there are formulas, right? There are also formulas. What's the formula? If you just want to know where the vertex is, what's the quick and easy formula for it? Do you guys know? What's the formula for h? It's really simple. Here's the formula. H is minus b over 2a. So this one has, what do we got here? A equals to 3, b equals to 6, c equals to minus 12. So minus b over 2a for this one is minus 6 divided by 2 times 3, which is, well, minus 1, right? And some of you are like, well, why don't you just tell me that to start with? Because Dad's not completing the square, and this is much happier. Fine. But if I told you that, you'd still be stuck with the trouble of how do you figure out what the y coordinate is for the vertex, right? Can you do that? If I tell you that the vertex is at -1, do you know how to figure out what the y is for that? All you do is you take this and you plug it back into the formula. If I plug -1 into here, that'll give me the k. So like k would be, so this is the other way of doing it. So f of -1 in this case would be 3 times -1 squared plus 6 times -1 minus 12, which is equal to 3 minus 18, also known as minus 15. So more than one way to skin a cat. At the end of it, we still have the desired outcome, right? One less cat. So, sorry, too violent. Cat lovers? Yes?
Or you only need the vertex and the x-intercepts to graph it, or do we?
Oh, well, what does it take to graph it? I mean, depends on what you want. But certainly knowing the x-intercepts and the vertex is helpful. I mean, I can also see the y-intercept with a minimum of effort. Like the y-intercept is minus 12, right? So like I can sketch this thing. My minus 1, like square root of 5 is about like 2.2-ish. So this is approximately minus 1 minus 2.2 minus 1 plus 2.2. So roughly speaking, the intercepts are at like minus 3 and 1.2, and it's got a y-intercept of minus 12. Oh man. Well, it's down there somewhere, I guess here. And the vertex is like where it's minus 1. So it's kind of like here. So I don't know, the graph is roughly speaking something like this. Here's your minus 1 plus root 5. Here's your minus 1 minus root 5. The axis, the vertex down here is minus 1 minus 15. I can't write down there. You write my labels, otherwise my lab instructor will take all my points. Sorry, I still have some bad memories from my chemistry labs. Anyway, yes.
Back to polynomials.
Ah, yes. Okay.
So if we can't factor it, does that make it prime, or does there answer?
So if we can't factor it, does it make it prime? And I think in practice, I have to be honest, I have to say no. Because not being able to factor something, like how do you know you can't factor it, right? Like that's a very kind of uneasy feeling for the student, because it kind of depends on like your factoring skill, right? So what I would say this, let me say this, if when you complete the square on a quadratic and you get a plus, then it's prime. Or, so there's two ways to go. Two ways to understand prime. So let's say prime, we're talking about ax squared plus bx plus c, okay? So is it prime? So here's the two logical paths I recommend going down. The one is complete the square. If you complete the square, and if you complete the square and you've got, you know, something squared plus number, right? If that's the pattern, then prime. The other way to do it, check the discriminant, b squared minus 4ac. If this is less than 0, then it's prime. Let me give an example. 2, I guess. So if we had, you know, x squared plus, I don't know, 10x plus 37. I complete the square on this thing. I've got x plus 5 quantity squared minus 5 squared, which is 25, plus 37. Clean it up, what do we got? X plus 5 quantity squared plus 12. Yeah, plus 12. Thank you. So it's this pattern, right? It's when we complete the square, we get number squared, the variable squared, variable term squared plus the number. It's prime. You cannot factor this over the reals. So like just something we should remember is any time you have, here's just, you know, you don't need to think about it, right? Like here's a fun fact, just remember this one. X squared plus any number, prime. If I'm assuming c is positive. If you have x squared plus any positive number, that's a prime. You can't factor, I mean, the only way you can factor that is to introduce complex numbers. Yeah.
For the one you did above, did you put minus 25 to cancel out the plus 25?
Yes.
Okay.
Yep, it's always that. It's just like we did to start. So, one more example. So let's see here. So if we want to factor this, let's say x to the 4th, I don't know, minus 5x squared plus 6. Let's try to factor this over the reals. How would we do this one? And did I say minus 5? I meant minus 7. Sorry about that. There we go. that what I want? Eh, fine, I'll leave it like that, yep.
Could you square root the whole thing?
Nope, we cannot just square root the whole thing. That is not allowed. It is forbidden. Yes?
You set x squared equal to a value we call z.
Ah, so you want to make a substitution. I think I'll allow that. Z, so you said make a z equal to the x squared. That gives you what? Z squared minus 7z plus 6. Now can we factor that? I think we can. I think we can use guess and check factoring for this one. So I'll write down my template, zz. I'm kind of sleepy. -6 and -1? Sure, I'll allow it. Why not? So, I mean, it's also correct. But, and then let's go back to x. What do we got? So we've got x squared minus 6, x squared minus 1. Now this is not like that pattern, right? It's not variable squared plus a number, right? It's variable squared minus a number. In that case, we can still factor. All right, and the way these are factored is just like this. X plus root 6 times x minus root 6, x plus 1 times x minus 1. Now, once you've got it down to the linear factors possibly repeated, you're done. Right? If everything you have broken it down to either a linear factor or a prime quadratic, that's as far as you can go. But the fundamental theorem of algebra says that that's always possible. So it's possible in theory. In practice, like there are polynomials which there's just no nice formula for the thing you're factoring out, okay? That's just the way it is. Okay, so I wanted to give you guys the quiz at the end of class just because I think that's a better sort of workflow in here. I probably am supposed to take attendance. So probably should do that, right? And I know you guys are just dying for me to top hat, so I'll do that too. So let's see here. If you can add a date to this, that would be lovely. What's today's date? 7th. Huh. So that means last class was the... Wait a minute, today was the... So today's the 7th. What was the last class was the 2nd? I'm going to put the 2nd there. That may be a lie. But anyway. So if you're here, mark yourself. Oh man, I had mission here the whole... I had mission. It was... Oh, this is mission 2. Never mind. You don't care about that. All right. So our topic for today, now that we're done reviewing, our topic for today is inequalities, polynomial inequalities. So how are we going to do those, do you think? What, did someone say cry? I hope I heard that wrong. Crying, in fact, will not solve your problem. It's true. Let's see here. Oh, so I was going to tell you guys. I went to the mall with my wife, and we went to. It was blue. They had blue jeans and black shirts mostly. Yeah, I know. So I went to this this place. It's outside the movie theater. The what's it called? The Papa. You guys know about this place? The Papagallo?
Yes. Yes.
It's very, very fancy. Except for like the whole view, like the mall views kind of ruin the ambiance a little bit, but if you could somehow like black out the mall views and the people waiting outside in the line, that might help. We tried the Mexican street corn. And so my valuable advice to you is don't get it. Because, like, no. Like, if you want to pay $7 for a can of corn with some, like, cream sauce on it, well, more power to you, but I don't think a can of corn is $7 yet, is it? I haven't checked. I mean, it could be for all I know. Now, I will say we had something called the Molcajete lava flow or something, and it was really good. But that street corn, my wife was hoping for, like, on a stick with, like, roasted, you know, because my wife asked the question, how exactly would you eat that corn? It's like corn in like a craft, like you might put gravy in or something. You know, it's like a little porry thing, like a little ceramic thing on this plank. It's like, who would eat this on the street? This is not Mexican street corn. No, it's not street corn at all. So my wife was very disappointed because she was hoping for like corn on the cob that had been roasted or something. And there are apparently two different schools of thought on Mexican street corn, it turns out. Anyway, so my important life advice for you guys is that there's another restaurant off Wards Road over there. It's called La Carreta.
Oh my gosh, that
And they have free chips, for one thing. They have free chips. The service is better. I will say I do like the spicy cheese at the Papagallo. That's pretty good. They could add that to the La Carreta, but just go to La Carreta. You know, if you need to go to Papagallo to impress your date, maybe that's not the person meant for you anyway. You know, don't start wooing them now. You got to save the woo for later. If it works out, you're gonna be with them for like decades. If you set the bar too high, you're just, you know, gonna disappoint them. So aim low. That's my relationship advice for you. Let's see here. I had the misfortune of my wife visiting my office before we were dating, and she visited my office when I cleaned it, which is like an incredibly rare event. So she had the misfortune of thinking of me as a neat person. And then we dated long distance for a while, and so and then we got married. My poor wife. She's a saint. All right, let's see here. So, oh yes, inequalities. Let's solve some polynomial inequalities. How do you think we're going to do that? We're going to use math. Is that what you said? All right. So the answer, how to solve polynomial inequalities, it's all about the factoring. So I'm just gonna solve a bunch of them. I'll show you the method. And each time the answer is going to be in terms of a interval or union of intervals. So let's see here. So all right, here we go. Check this out. Suppose you want to solve x minus 1 times x plus 3 less than or equal to 0. The way we're going to solve this is we're going to identify where the polynomial could be 0. So in this case, I'm going to call them critical numbers, because that's kind of what's critical. Critical numbers are 1 and minus 3. Those are the numbers that make that polynomial 0. All right? Next, I put these numbers on a number line. All right? And I put them in order, right? Which comes first, minus 3 or 1? Going left to right. Minus 3, that one's the smaller number. Then you got 1 over here. They don't have to be to scale, but here's your number line. And what I'm graphing here is the sign, all right, the sign of that expression. So here's what we do. Plug a number in. So if you test let's say 0, what happens? 0 is between -1 and 3, right? So I can test 0 there. I'm going to test 2 over here. I'm going to test -4 over here, okay? Why do we what?
Why do we flip the signs?
Because we're looking for where it's 0. So the factor theorem, remember, says that f of c is equal to 0 if and only if x minus c is factor. So there's always this flippity-flop of the sign. What makes the polynomial 0 versus what you find in the factor. It's the negation. If I have an x plus 1 factor, that is 0 when? What? X plus 1 is 0 when x is equal to -1, right? So it flips. Does that answer? Okay. So that's why I have to put -3 and +1. Yeah. Good observation. That's important. Now, I'm saying we can plug in -4, 0, and 2, right? So what happens? Let's call this thing f of x to give it a name. So what's f of -4? What's that equal to? What's f of 0? What's that equal to? What's f of 2? What's that equal to? Yeah?
0 is 0.
0 is not 0. 0 is
Oh, wait.
-3. How about -4? What'd you get there? So I'll do it. I mean, so I go -4, -1, right? You just put -4 in for x, okay? That's what we do. What's going on here? Well, I got -5 times -1, so the answer here is 5. All right. If I plug 2 in, I get 2 minus 1, right? 2 plus 3, what's that work out to?
Can you explain the top one, the f of the negative f
How can I explain the top one?
No, like the f of -4. Like I see the -4, the -1, and -5, and then you got -1 with that. But then how did you get the positive 5?
Because -5 times -1 is 5.
Oh,
That's all. Uh-huh. Is this going to be 5 too? No, I think it's just going to be 5. Sorry, I'm just being, that was uncalled for. Sorry, I'm an idiot. Listen, the thing is we're working way too hard right now. All that really matters to us is the sign of these points, right? All we're really interested in seeing is that this is plus, this is minus, and this is plus again, right? So, because we're just interested in solving this inequality, and that's all we need to know is the plus and the minus. So, so in this test point, we had plus, then we had minus in the middle, and then we had plus over here. Listen, this is totally unsurprising, because what's the graph of f of x look like, by the way? You got a y-intercept of -3, you got a y-intercept of 1, it opens up, right? So the graph of the parabola looks something like this. I don't usually graph, I'm just saying this here so it helps some of you see what's going on. We're trying to understand what's the sign of this expression. The graph of the expression looks like this. So of course, it's only negative where? Where it dips below the x-axis, which is in the middle on our number line. So what's the answer then? Because our whole problem here is to solve this inequality. All right. So the answer is, from this number line, I can see that the solution set is -3 to 1. And they're both included. Why? Because we're looking for less than or equal to 0. So we would include those in the solution set. All right. Let me do another. Example 5. Suppose we're solving x squared minus 9 times x squared plus 6x plus 9. Oh man, that's not what I want. Sorry, 8x plus 16, there we go, better, is greater than 0. So in order to solve a problem like this, the first thing you need to do is to have it factored, all right? So we're going to factor this thing. Factoring, I get x plus 3, x minus 3. This is what? X plus 4 quantity squared. Very good. And we're trying to solve that's greater than 0. Okay? We could call this expression f of x again for the sake of reference if we wanted. I'm not going to even bother. What are my critical numbers? -3, +3, and -4. Now we put those on a number line. All right? Put them on a number line. And which one comes first, left or right? -4? Okay. What comes next? -3 is next, right? And then you got 3 over here somewhere. Now they don't, again, it doesn't have to be to scale. Just logically, we want the sequencing of the numbers to be correct left to right, okay? Smallest to largest in magnitude negative to largest in magnitude positive, right? Number line. And I'm going to be lazy and call this thing f of x to save myself the trouble of writing this again down here, if you don't mind. Now, we need to test points in each region. The logic here, guys, is that the only way a polynomial can change sign, go from plus to minus, is when it does what? When it crosses the x-axis. So if I can determine where it's positive and where it's negative, whether it's positive or negative between each x-intercept, like divide those up into subregions, then I completely understand the sign of it everywhere. So that's why the critical numbers are critical. Once you figure out what the critical numbers are, those show you the possible places where the sign can change. So then, if I figure out what the sign is in each case, I completely understand how to solve the inequality. Does that make sense? So this is the method. Write down the critical numbers, write down the number line, test points in each subinterval to determine whether it's positive or negative. Now, which points do you want to pick? It doesn't matter, right? Whatever. So if I plug in 0, that's here, you know. I can plug 0 in. When I do that, I get -9 times 16. That's negative. If I plug in 0, I can see it's negative. I don't even care what the value is. The point is it's negative. I can plug in 4. What happens there? See, look at this expression. At 4, you have positive, positive, positive. Plus, plus, plus is plus. So product of pluses is plus. What happens if, what's between -3 and 4? How about this? -3.5, I could plug that in, yeah? If you plug -3.5 into this expression, what happens? -3.5 plus 3 is what? Negative. So this is negative. -3.5 minus 3 is -6.5. This is negative. So if you look at it, what you've got is you got a negative, and positive. What's the product of two minuses is, again, plus, right? So I got plus here. Now, how about over here? Well, we could plug in, like, I don't know, -5. The test points I'm picking, how did I pick them? There's no, like, hard and fast rule. You just need to find a point to test. It doesn't really matter which one. All right? As long as it's in the correct place. So -5 is over here. -5 plus 3 is -2. -5 minus 3 is -8. So we got minus a minus. This is still plus, right? Because this is irrelevant to the sign, isn't it? Because it's a square. Think about this. A square is always non-negative. So like we keep thinking about this factor, but we don't really need to because this already is predetermined positive. No matter what you put in, plus or minus, when you square it, it's positive, right? So like this x plus 4 squared term actually doesn't matter. So we got plus here again. So there's a theorem I always mention, and the theorem is this. The sign flips for critical numbers associated with, let's say, c, x minus c to an odd power. Sign does not flip across c with x minus c to even power. So like, how's that theorem? I call this the sign flip theorem. See, notice that minus 4 corresponds to x plus 4 squared, right? So the sign does not flip across that critical number. It stays plus. See that? But on the other hand, minus 3 and plus 3, those correspond to x plus 3 and x minus 3, you know? And those are to the power 1, that's odd. You see you're going from plus to minus, or from minus to plus. There's a sign flip. If you understand this theorem, you only need to test one point, and then you can propagate the sign through it. Okay, so before I get distracted by the sign flip theorem, can you tell me what the answer is here? We're trying to solve greater than 0, right? Yeah.
So wouldn't it be negative infinity to negative 3, union 3 to positive infinity?
So minus infinity to
negative 3.
negative 3. Well, I can't do that. And the reason I can't do that is I cannot include 4. See, because 4 makes this expression 0. So that I have to, that's out. Now, if it was greater than or equal to 0, you'd have been right. But because it's positive, we just go to minus 4. We have to exclude minus 4, which we do like this. Then we go to the minus 3, like you said. And we're also excluding minus 3 because we're looking at positive and not 0, right? And then we take the union with 3 to infinity. But yeah, there you go. The cool thing about this method is once you've solved it, you can easily solve a corresponding problem, right? Like what if my example 6 was the same expression, right? But if I had f of x less than or equal to 0, what would the solution be in that case? So this one's kind of weird. The interval notation lets us down a little bit here. Less than or equal to 0, I would have just the number minus 4. That's one part of it. So I do minus 4 by its lonesome, like that. And then I would take and union that with minus 3 to 3. They're both included. And there you go. That's the solution to this related but different problem, f of x less than or equal to 0. Because I can look at the number line, where is it less than or equal to 0? Well, minus 3 to 3. And the critical numbers make the expression 0, so I have to include all of them in the solution set. So this is annoying, but this is called a singleton. You know. So. Let's look at another. This time I'm going to use the sign flip theorem and kind of try to illustrate to you the power of it. So let's see here. Example 7. What if I'm up against, gee, I don't know, x minus 10 times x plus 6 cubed, x plus 2 squared times x minus 5 to the 4th power times x plus, oh, I don't know, 7. There we go. So what are my critical numbers? And I want to solve this as, let's say I want to solve where this is less than 0, okay? So what are my critical numbers for this one? I got a 10. What else you got? Negative 6. Negative 2. 5. Negative 7, right? Now I need to put those in order. Which one comes first, reading left to right? I'm gonna call this thing f of x because I don't want to write it again. So this is the number line for f of x, okay? So what was that? Negative 7, okay. And then what comes next? Negative 6, all right. Then what's next? Negative 2, okay. And then what? 5 and 10, okay. So oftentimes the easiest thing, I mean, for me, one of the easiest things to do is to think about a really large positive number. Think about putting a really large positive number into the expression. What happens if you put 1,000 into this thing? Is this positive? Yep. Is this positive? Yep. Is this positive? Yep. Is this positive? Yep. Yep. So it's positive, right? So if I plug 1,000 in, it's definitely positive, which gives me this plus right here. Now I'm going to use the sign flip theorem to generate the rest of it. Check it out. So 10 corresponds to what? This one here. That's an odd factor, right? Which means I flip the sign. I get to 5. What's 5 correspond to? 5 corresponds to this one, x minus 5 to the 4th power. That's even. What that means is when you sort through it, it's not going to flip the sign. It's going to stay minus as we go across that critical number. Minus 2, what does that correspond to? Well, that's from this guy. Again, even. So you know what happens? The sign, it does not flip, like so. And then what? Minus 6, where's that coming from? This one. 3. 3 is odd. Odd power flips the sign. So we go plus. And then minus 7 corresponds to this one. Again, that's the first power, which is odd. So we flip the sign yet again. And you can check me. You can try plugging in a number into any one of these subregions to see that you actually get the same sign as I do. But I think you can agree with me that knowing the sign flip theorem is much more efficient than actually plugging numbers in to every case, right? Like even in this much simpler case, it took us about 3-4 minutes to plug the numbers in carefully. And that's good experience for you guys, and you should do it, but it's nice to know this theorem. Now, so what's the solution? I want less than 0. What am I looking for? Solution set equals to what? So I'm looking for the minuses. That's where it's negative, right? So we've got minus infinity to minus 7, union what? Minus 6 to minus 2. Oh, and then minus 2 to 5. And then 5 to 10. And I think that's it. If I had f of x, instead of less than 0, if I had less than or equal to 0, then what's the solution set then? Then it's easier, because if we're including equals 0, we don't have to exclude those joining points. And so like the answer would just be minus infinity to minus 7 unioned with, well, we can go all the way from minus 6 all the way over here to 10. So it's much easier to write the answer down if we're including 0 as a possibility in the inequality. Yep.
Wait, we flipped the sign.
Uh-oh, did I mess it up?
I'm confused on which sign
We're flipping, what we're doing is we're flipping the sign as we go across the critical number. So if I started with the plus, remember I plugged in 1,000? So that's my starting point. And since 10 is corresponding to that x minus 10 factor, which is an odd factor, I go from plus to minus. That's the idea. Here, 5 is this x minus 5 to the 4th power, that's an even. So I don't flip the sign, I just stay minus to minus. So that's it. I mean, now if you don't like the sign flip theorem, you can just do what? You can test a point in each subregion. But this is how we solve polynomial inequalities, and we can solve them all, right? Well, when can you solve them? You need to be able to do what? Factor them, right? So final example for today. Can you solve this one? So think about this. This is x plus 2 squared minus 4 plus 5 being greater than 0, which is to say x plus 2 squared plus 1 greater than 0. What are the critical numbers for this one? When is this 0? Is there a critical number? So this is never 0, right? For real x, anyway. So there is no critical number. The number line is exceedingly silly. It's just this. And so what does it look like? I wouldn't even bother with a number line here for this example, honestly, guys. I'm just doing it to be like logically, coherent with the other examples. So I just plug in a point, like plug in 0, right? What happens when you plug a 0 in? You get 5, right? So here's your number line. If I graph this parabola, what's it look like? Where's its vertex? If I graph y equals to x plus 2 squared plus 1, where is it? Well, its y-intercept is 5, right? Where's its vertex? Its vertex is at where? What's that? I didn't hear you. Where's the vertex? What makes this smallest? We plug what? We plug minus 2 into that, right? Or, if you like, h equals what? Minus b over 2a, right? So that is minus 4 divided by 2. It happens at minus 2. So at minus 2, comma 1, that's your vertex. And so this guy looks like this. So is it positive? Is the value of the function positive everywhere? Absolutely. What's the solution set? Everything, minus infinity to infinity. So understanding graphs